All right, so this video is about graphing quadratics. A quadratic, of course, is those parabola things. It's either up or down. Applications are, like flight of a ball or any projectile shot, that kind of stuff. There's those kind of applications for quadratics. There's also something called conic sections, which we'll do later on. There's some really cool applications of parabolas. But for everything so far here, it'll be like flight of a ball or something like that. But we need to graph it. In every single parabola, we need to know the vertex. We have to know the vertex. So the vertex is the top of it. And so there's a couple of different ways to find it. Depends upon which form we have. So this is graphing quadratics, and we're going to look at 3 different forms, but the non-conic type, we'll look at that later on. Okay, first type. First type is actually vertex form. We're going to go and do. And so it's of this nature. And so it's a shifted graph. So vertex form, it's really nice because it gives us the vertex. It's HK. That's so handy about it. And then remember, of course, A tells us if it's opening up or down. If it's positive, then it's opening up. That means like this. If it's negative, then it's opening down, or like this. So that's that kind of thing. Now, your very simplest form of a vertex form is one that does not have a vertex other than 0. So let's say 3x squared minus 1. So x squared is right here. Now that is not very good as a parabola. But anyhow, this graph is going to be shifted down 1, and it's going to grow 3 times faster. So it's going to be like 3 times skinnier than that thing. So that'd be just a quick sketch of it. Now, how could we make it better? We could make a table and actually plug in points. And it's really good to use 5 points here with the vertex being in the middle. So the vertex, since if we go back to the top here, there's nothing on the inside here. So what makes this 0? Well, that's 0. So if I plug in 0, 1, and 2, and -1 and -2. The wonderful thing about quadratics is there is symmetry. So these outside ones are going to have the exact same value. So if I plug in 2 into this, remember 2 squared is 4, then multiply by 3, and then subtract 1. So it's 11. If I do the same thing with -2, you also get 11. If I plug in 1, I'm going to get 2. -1 also would be 2. If I plug in 0, it'd be -1. So if I want to make that a better graph, so 0, -1, obviously having a grid would be helpful instead of my chicken scraps there. And then 2, 11, well, go up there, and -2, 11. And you get yourself a nice, make those dots a little bigger since it didn't go through it. And there's your nice graph. So that would be vertex form where it's at 0. Well, if it wasn't at 0, say 3, and it's x minus 4 squared plus 1. How do I know it's a quadratic? Because of that square. If say that was something besides a 2, then it would not be a parabola. So like a 3, it looks something different. If it's a half, it looks like something different. So again, we're looking at parabolas here, or quadratics. So it's what makes the inside 0. Always think about these things as what makes that inside 0 anytime you have it in this format. And so 4 makes that 0. And if I were to plug in 4 into this, if I plugged in 4, I'd get 4 minus 4, which is 0. That wipes that out, and you're left with 1. Hence why that's the format. So 4, 1 is my vertex. So 4, 1. And if I went 2 numbers each way to graph this, I can plug those numbers in. So if I plug in 3 here, I made a mess up top here, but if I plug in 3, I get 3 minus 4, which is -1. -1 squared is a positive 1, right? And -1 squared is a positive 1. And if I do that, I'm going to get 4. And likewise, if I plug in 5, it'll be 4. If I plug in 6, I'm going to get 3, and I'm going to get 2 squared. And so that's going to be 13. 13. So again, this symmetry holds true. The vertex does not. And so if I graph it to 13, it looks something like this. Just a quick sketch here. 4, 1, when you graph this, make sure it's not a V, because that's a different type of graph. That's the absolute value graph. It's really pretty rough there. And so that's in vertex form. If you have, say, let's say x plus 2, let's see, not use 2, let's use plus 5 squared. Now, let's make that a negative here, -1/2. So -1/2, hopefully you're listening because that's negative. So this graph here, there's things about that you should know. So what makes the inside 0? Well, it's -5. So the vertex is at -5. And so if I go up and down, so this one's not nearly as nice because it's a fraction. But the reason why I made it a fraction is so it's going to go down. So it's at -5, -1. It's going to go down. Instead of being skinnier than the original, like this thing is actually skinnier. It's actually, come on, it's actually 3 times skinnier. This one is going to be fatter. So it's going to be like wide, big fat graph here. You'll have graph paper to graph that on. So if I plugged in, say, -4, I'm going to get -1.5. If I plug in -6, I also would get -1.5. If I plug in 2, or not 2, but say -7, I believe I'd get 1. My mental math is correct there. 4 times -1/2. How about not? That's not 1. That is not 1. -3. There you go. And so we get ourselves a graph. So that's vertex form. All right. The next one is standard form. Standard form is the ax squared plus bx plus c. This is the form you would see for projectiles. There's a standard form for projectile, shows initial velocity, etc. And it's, so h of t, this is the standard form. A of 16t squared instead of using x. So with the standard form, this is what you end up looking at. But the big thing here with the vertex is -b over 2a. So looking at right here, so this is b, and then twice a. So you're looking for those to figure out your vertex, and then you set up your table just like any other ones. But you should know if it's opening up or down again, because if a is bigger than 1, if it's positive, not bigger than 1, if it's positive, then it's opening up. If it's a is negative, then it's opening down. So you need to know that. That should be a speed automatic, that sort of like a safety check when you're typing in a calculator. Say this is -3x squared plus, we'll go 6x plus 2. In graphing this, we need the vertex, which is -b over 2a, so twice a, so -6 over twice a, so 2 times -3, which is also -6, gives me an x value of 1. So we get our table, 1, and we go each direction, 2 numbers. So that will keep our symmetry. So when I go back, this one takes a little more work. I'm going to plug it back in for every x. So like if I plug in 3 into this, I'm going to get 3 squared plus 6 times 3 plus 2. And you should be able to do this without a calculator, or without a calculator, I guess. Get -7 there. And so then that makes -1, -7 also. If I were to plug in the next value, I can plug in 2, or I can plug in 0, because they're going to give me the exact answer, same answer, the symmetry. And then I can, of course, plug in the middle one, which is the vertex here. And so that's going to give me 5. So this thing was opening down. We knew that from the go. And so 3, -7. And then 2, 2. And 1, 5. And 0, 2. And finally, -1, -7. So you've got this beautiful looking quadratic that would look like so. In a story problem, you might have, so you've got that equation. It depends if you're in feet per second So this is in feet per second. So that's why we use negative 16. That's half the gravitational constant, which is 32 feet per second. And so you got your initial upward velocity and your initial height. So we'll say some object it's shot from initial height or thrown. So let's say initial height of, let's say 5 feet. And notice we're in feet, and that's why that's negative 16. If you're in physics class, they often will use meters per second. So then this would be a meters problem. And so we'll say that it had an initial upward velocity, and so this is going directly up. All right, if you want something that's going on an angle, actually, then that's going to be a parametric equation. Interrupted there. Let's see, initial upward velocity of, let's say, 120 feet per second. Okay, so you'd have an equation, and so we've got negative 16. That's an automatic because it's a gravitational constant. And again, we setting this up in t instead of x because it's representing time. It's upward velocity, so it's positive. If it was down, if it was thrown down, then it would be negative, but it's thrown up, it's positive. If it was just dropped, then that would be 0. And so to figure out how high it went, so like this is a good story problem that you need to be able to do, just a good application problem. The highest point is the vertex, of course, so it's something like, looks like this on a graph, but don't let that fool you. This is not horizontal change. This is only time. Okay, again, parametric equations would be something that you do in pre-calc that would bring in and allow for horizontal movement. So in data and algebra 2, we simply do only vertical movement instead of any horizontal movement. Okay, so negative 120 over twice a, so negative 32. So this is a story problem, so it's not going to be a nice whole number, which is 3.75. So at 3.75 seconds, it reaches its peak. It starts at 5 feet right here on the y-intercept. That's the y-intercept. Because if I plug in 0 seconds, 0 for the t's, those will cancel out. And 3.75 seconds. And so if I plug that in, maximum height of 230 feet. So up here, it's 230 feet high. Now, we'll want to also know when the thing hits the ground. We'll talk about that in a later video, finding out to solve for that. Or we want to know like when it hits a certain height, say like at, when does it get to 100 feet high? We can graph that in our calculator, and we could do like, you could graph the original equation, and you could do the second equation, be y equals 100, and then you do the second calculate intersect. And that's pretty handy, second calculate intersect. You can solve that too, which is really quite useful. All right, so the next one, the third one, this is in factored form. So quadratics, we love to have these things factored if possible, but most of them are not factorable with nice numbers. So factored form, it's in this form here, x minus m, x minus n. So factored form, let's say that let me just give you an example here. So like if I had, say, 2x minus 3, x minus, let's go x plus 5. Like this right here is a quadratic. It doesn't have a square, doesn't have a little square up there, right? But if I were to FOIL this thing out, I would get x squared, put the 2 out in front, x squared, 5x, and I get negative 3x, negative 15. And so then that would become 2x squared, 2x minus 15, distribute, and you get 2x squared, 4x minus 30. So you can see that this thing could be in standard form, like the problem before. That's standard form, right? Just like that. It could be just like that. Or it could be factored. Factored form is a really nice form. And so in a factored form, you just got to find m and n, meaning the x-intercepts. And you're going to find the vertex, just like always, but that's the average of those roots. So roots are the point where it crosses. So it's what makes it 0, so 3. And then what makes the other one 0, negative 5. Because again, it's what makes these 0. And so then halfway between 3 and -5. So 3 and -5. So if you average those two, that means add together and divide by 2. That would give you -2 divided by 2, which is -1. So my vertex is at -1. So this is, we haven't talked about that, the line of symmetry, LOS. So at -1. So I can go back and plug in -1. And you see that you actually really only need 3 points to graph a quadratic. So when it's in factored form, 3 points is sufficient. So that's -4, 4, and if you multiply that out, it's going to be 32, -32. So we knew it was opening up because this was positive. So -32, and this is okay to graph it this way, -1, comma, -32. Just labeling that point on that line of symmetry, and voila, you get yourself a beautiful graph. And so that's, again, that's factored form, so that's the third format of this. They can all be interchanged. There's something called completing the square. They could take a standard form that we just had and put it into vertex form, and that's later on also. All right, so these are 3 different types of graphs. All of them need the vertex, and you need at least 2 other points. Factored form, you need 2 other points. Standard form, I want you to go and give me 5, and vertex form, we also want 5. And the vertex is the middle of that table. When we set up that table, the middle is the vertex. All right.